force current in amperes will deposit 2.7 grams of aluminium in 2 hours. After calculating, we identify the correct answer. Now, for us to calculate the current, we must first have in mind that according to first law of electrolysis, that is Faraday's first law, Q is equal to IT. From first law, mass is equal to the quantity. The mass is equal to the quantity, and the quantity, just as I said, is equal to the current times time. Current times time. So this is the formula we'll be applying here. We already have the time given. The current is what we are to look for. Now, first we'll calculate the quantity of heat produced or liberated. Now, for us to begin with that, we must first understand that 1 mole of aluminium is 27 grams. Needs or require 3 electrons, and by 3 electrons it means 3 Faradays. Now, how many moles of aluminium is actually used here? How many moles of aluminium is actually used here? From the mass, we can note that. So it is 2.7 grams. 2.7 grams. Now, it will give us how many Faraday, that is the quantity of heat. We just go direct in column. Since this is 3 Faradays and 1 Faraday is the same as 96,500 column. So this is the same as 3 times 96,500 column. I hope that is clear. So it now means that when we multiply this and this, we will now cross multiply. It will be the product of 3 and 96,500 column times 2.7 grams, then divide by 27 grams. When we do that, we'll now have 3 times 96,500 now times 2.7 or divide by 27. So this is what I'm saying. Instead of writing question mark there, it becomes 2.7 grams times 3 times 96,500 column divide by 27 grams. So gram cancel grams. So finally we have 28,950 column. Now this is the quantity of electricity that was produced in this electrolytic process. Now we go further to employ the formula Q is equal to IT. So where there is Q, this is the value, the quantity of heat, and then time is also given to us as 2 hours. Then we look for the current. We look for the current in amperes. Now we can make current subject formula. Making it subject formula would mean we are dividing through by T, which is the coefficient of current here, divided by T. Now, cancel T, therefore, current is equal to Q over T. Now, current is equal to, what is the quantity of heat? 28,950 divided by, what is the time? The time is 2 hours. Now, because it is in hours, we must convert it to seconds. Now, 60 seconds makes 1 minute and 60 minutes makes 1 hour. It therefore means that we convert to minutes by multiplying by 60 and then also into hours by multiplying by 60. So it becomes 28,950 divided by 60 times 60 gives 3,600 times 2, that is 7,200. 28,950 divided by 7,200. 7,200. That is 4.0 amperes. 4.0 amperes. So the current that will deposit 2.7 grams of aluminium in 2 hours is 4.0 amperes. Now let's check the option. This is 4 here, so this option C is correct. If you have not liked, please like my videos, share to others, let them benefit. Click on the notification bell. Always comment. Thank you.